Um, so in the previous tutorial, we have seen how we can set up this sort of a dynamic data-driven locomotion system, and there currently we have set up the idle stance animation only. And now let's see how we can maybe improve it further for a, like, let's say, idle brake animation state, right? So instead of showing this specific idle animation for a quite long period of time, maybe by waiting sort of a random delay, like let's say after 3 or 4 seconds, it will play some idle brake animation and go back to the idle state again, right? So it will be bit more realistic, and it will be good user experience for the player as well. Okay, now let's see how we can set it up. So first, since we have this data oriented design now, or data driven architecture, we can start from the data layer onwards when we are scaling our locomotion system. So first, if you remember, we have created this data structure called set at data struct and locomotion folder. So maybe we can start improving from this position onward. Okay. So first I'll add a new field called idle brakes. So there can be multiple idle brakes for a specific anim set. So I'll make this as anim sequence as by default, but it should be an array. Okay, now if you go to the data table, here you can see that the specific field is there, right? Then we can go to our ABP locomotion and in blueprint, and there we can go to this set anim set data and go to this set idle. Now you can see we have one more field has been added to this brake data structure. So let's promote it to a variable called, yeah, as the name intended, it should be idle brakes, and the category should be anim sequences, and I'll plug the execution pin like this. Okay, so now we have our idle brakes references initialized here. So you can see like it's quite fast when we have properly set up this thing, right? So it's just a few steps. Okay, now we need to implement this idle brake specific logic. Yeah, so to do that, since we have a set of idle brakes, we have to start from a default idle brake sequence onwards. So in order to track what is the idle brake sequence that you're playing right now, I'll track its index. Maybe I can create a new variable called current idle brake index, and it should be an integer, and I'll assign it to a category called idle brakes. Okay, and by default I'll make the current idle brake index as 0, and at the initialization, when it call this event onset anim set event, I'll go there, and before this set animation data instance, I can initialize this current index like this. Okay, so before initializing any sort of any sequence references, it will first set this sort of global variable inside ABP locomotion, right? For instance, I can set current idle brake index as 0. and then and then it will go to the set animation data, and it will go to this collapse stage and set this idle break reference. And maybe I can improve the name or the title of this collapse graph. Maybe set idle and idle breaks. Idle breaks. Okay. Now let's go to the anim graph, and there let's go to the locomotion and idle and idle state machine. Wait, am I at the correct hierarchy? Locomotion, idle, idle state machine. Yeah, inside idle we have idle break. So there, like we did before, let's add a sequence layer, and for the onUpdate function, let's add a new function, and I'll name this as setup idle break anim layer, and assign it to the anim node functions, and let's get the context and convert it to not the context, actually. I get the node and convert it to sequence player, and I'll set sequence. We don't need the initial blending because we are playing it at one time. And I'll get some anim instance from this array. So currently we are taking this current idle break index as 0. So I'll take the initial one and assign it to the sequence. Okay. And then maybe we can, after setting this up, we can increment this current idle break index. So at the next idle break instance, it will play a different idle break animation instead of the this 0 index 1. So let's increment it like this, and also whenever it reaches to the end of this list, it should set the current idle break index as 0. For example, let's say if we have two idle break index, first the idle break index value should be 0, and it will increment and it will become 1, and it will play the second or the first index related any sequence for the idle breaks, and then it will increment, but it shouldn't go up until the 2 because there is no index reference at this array if it has only 2 elements, right? Because the last index should be the 1. Therefore, if it reaches to the end of the iteration or end of the array, this idle break index should be reset back to 0. Therefore, what we can do is we can get the length of this array, and we can check whether we reach to the end. So it can be either greater or equal, and if it is reached to the end, it will simply set the current idle break index as 0. Okay, so this is the setting part, and if everything works, everything has been set up properly, we have to return from this function like this. So basically we are taking our first idle break sequence and set it up to play that idle break animation, and we are incrementing the index, plus if it reaches to the end of the idle break animation list, and we are resetting it back to the 0. Okay, and now as usual this is showing this error because we have to set this sequence as dynamic. And yep, once we set it as dynamic and compile, that error should be gone away. Okay, and then we have this idle break state and idle stance state, and we need to make a transition based on a specific rule. So these rules will be designed or defined like this. And for instance, let's say we need to trigger this idle break animation after a specific idle break interval. So maybe I can create a new variable called time until next idle break, and I'll make a float value and assign it to the idle breaks category. And let's define this idle to idle break state transition rule. So first I will check whether the time until next idle break has been ended, or has been that interval has been ended, plus whether we have a valid idle break animation to play within this array. So if it has a valid element, the length of it should be greater than 0, like this. And if everything surpassed, then the result should be set. Okay. So this is the transition rule to jump this idle break. But now we have to set this time until next idle break. So in order to do that, what we can do is maybe we can create a new function to set these values dynamically. So let me quickly look at my documentation. Yep. So to set up these values dynamically, maybe we can go back to the idle stance layer. Not there actually, here, the idle stance input state machine. And once this idle stance has been set up, similarly we can initialize our idle state layers, right? So so first let's initialize or let's say on become relevant. So whenever this function has been triggered, this output animation pause will become relevant. So whenever it becomes relevant, let's create a function called maybe setup idle state layer, and I'll assign these to another category called state node functions layer. Okay, pass that here, and Yeah, here we can define um, where to set our idle break plus how the idle break transition logics has been applied. So for that, I will create a new function called maybe choose idle break delay time, and assign it to a category called idle breaks layer. And there, first before setting this time until next idle break, let's create a new variable called idle break delay time. Okay, and I'll set it here. And for now, I will choose a random floating range, but later on I will show you a better approach. But right now I'll make maybe like minimum 1 second and maximum 3 second, and it will set idle break random delay time, and as a category I will assign it to the idle breaks. And then let's call that choose idle break delay time function here, and then it should set this time until next idle break according to this specific idle break delay time value. So in order to do that, I'll create a separate function called reset idle break transition logic, assign it to the same category as before, and there for now let's set up this thing as our idle break delay time. Okay, so basically idle break delay time is a random value, and we are setting that random value as the time until the next idle break. And yeah, so I think this is a good position to introduce a thread save function. So here you can see it says animation error called this is not a non thread safe animation, because in Unreal Engine 5 now they are following this sort of threaded multi-threaded approach for playing animation. So therefore this sort of state layer animation, it requires to make our functions as thread safe, so it can be multi-threaded by the engine itself. So in order to make our function multi-threaded or thread safe, you can go to the advanced and first select the function and go to the advanced and make it thread safe and compile it back. Now the error has been gone. Okay, and then we can attach this reset idle break transition logic function as well and compile it back and make sure it is thread safe as well. Yeah, so yeah, unfortunately this random floating range thing can't be used because by default this is not a thread safe function. Therefore I'll remove that thing and I'll hard code this value for maybe like 2 seconds, right? But later on I'll show you a better approach to set a dynamic value for this specific idle break delay time. Okay, now we have set our time until next idle break at here, and then you can go back, and after this thing is updated, what we can do is we can process our idle break logic, which means like resetting it. So let's create another binding for that as well, and I'll name this as update idle state layer. Okay, and this thing also goes under this state node function layer. Okay, then so whenever our animation has been played out, we have to reset this time until next idle break. So therefore I'll get the context and I'll check whether state has been blended out, and I'll convert to maybe animation state, and if it is blending out, then I can reset our idle break transition logic. If it is not blending out, we can process this further. So maybe to do that, I'll add another function called process idle break transition logic, because we need to decrease that time until the next delay, next transition logic. So as the input, I'll get the delta time, so we can make some updates to our values, and I'll go back and I'll assign that process idle transition logic function here, and I'll get the context and get the delta time and assign it to here. So this delta time is globally applicable at anywhere at our locomotion blueprint. So we get that delta time and pass it to this specific function, and let's implement this function. So first what we need to do is we have to check whether we can actually play the idle breaks. So maybe we can implement sort of a helper function. Let's say can play idle breaks, and I'll assign it to the idle break layer, and maybe we can make it as a pure function and make sure it is thread safe. And let's get this idle breaks, and let's check the length, and if it has a positive value, it is valid, so we can return it like this. And then you can go back to the process idle break transition logic, and let's check whether it is valid. If it is valid, we can slowly decrease our time until next idle break, because if you remember, initially we set this time until next idle break as idle break delay time, which is for now the hardcoded value, but ideally should be a random value. And now for each update, it should decrease this time until next idle break. So whenever it reaches to the 0, it jumps to the idle break state from the idle stance, and it will play that specific idle break animation. Okay, that's the logic. Okay, so I'll set this thing, but we should decrease it alongside the delta time. So let's say the idle time until next idle break value is 2 and the delta time is keep increasing, so this value is keep decreasing along the time, and we have to set it like this. Okay, that's the first part. And let's say if we can't play any idle break, then we don't need to make a transition. Therefore we can simply reset the idle break transition logic. Okay, let's go back. Yeah, make sure to make this as thread safe as well. And then once we processed our idle break transition logic, we can safely return from this update idle state layer function. Okay, so bit of a complex logic is applied there, but the idea is simple. Basically, the goal is to set a initial random idle break delay time and decrease it along the way when we are playing the animation states. Okay, now you can see on become relevant and on update functions are triggering, and we can go out of this idle stance and we can go back to this idle break logic, and here you can see whenever it reaches to the 0 and if it is a valid idle break, and I think we can use that helper function here as well, so the code will be much cleaner. And if it is reached to the end of the delay, and if we can play a idle break animation, then this one jump to this idle break state and it will start to play a idle break animation for us. Okay, great. Now if I play it, nothing will happen after 2 seconds because I haven't set up our idle breaks at here. But first I will switch this back to the unarmed anim set, and if I play it again, you can see now the character is at the unarmed idle state. And here let's set up some idle break animations. So there's a one called unarmed idle break. Yeah, there's one called fidget and there is another one called scan. So there are two separate idle break animations that I been assigned here, and now let's try to play it. 1, 2, okay. Actually you can see it's playing, but it's keep playing and it's flickering right now because it happens we haven't made a return in transition logic from our idle break. You remember, this is our state machine. We haven't add any rule or logic to get out from this idle break state back to the idle stance state. Okay, so let's add that as well. So first I will add multiple different transition logics, but first I will make an automatic rule based sequence jump by simply taking this value, and if I play it again, you can see bit better. You can see after 2 seconds that thing has been gone, but still flickering is there. Okay, let's see how we can fix that. Yeah, maybe we can add another jump. Let's say we are checking if we can't play any idle breaks, we are returning it back to the idle stance state as well. Okay, that's the second rule. I'll make the priority order as 2. Yeah, and yeah, I think those 2 logics would be enough, and let's try it again. Okay, it's playing, but seems like it's flickering. So let's see why is that. Yeah, so I debugged the issue and I found it. Actually, this is the issue. So if you remember, at the idle break sequence player, it should set up the idle break animation at the on become relevant state, right? Not the on update state. What happened is like if we set up our idle break animation for each update, it will start this flickering, right? Because it try to update the animation state again and again for each frame. So therefore, let's remove that binding from here, and instead of that, let's attach it to the on become relevant. Let's compile and save it back and play. Now you can see after 2 seconds that guy is playing idle break animation, and again another 2 seconds the next idle break animation, and let's wait another 2 seconds and again back to the idle break animation. Okay, so that's how we can play actually the idle animation, but maybe we can improve this further. So one thing is like we can add more and more transition logics to this idle break layer. For example, let's say even if we changed our anim set dynamically at runtime, the character should stop playing idle break and jump back to the idle stance layer. So maybe we can set that thing as here first. Let's create a variable called anim set change, which is boolean value, and I'll assign it to a category called character state data. And maybe after initial setup, the anim state has been changed, and let's wait for a random delay, maybe like 0.1, and I'll make this anim set change back to false, because that transition or anim set changing has been happened already, so it should be false. So this will prevent some sort of critical race conditions when we are initializing our animations. So that's why I added this thing, and we can use that logic to drive another transition rule from idle break to idle stance state. And let's go inside here and let's attach this anim set changed. So if this is true, this will simply jump back to the idle stance layer again. Okay, great. Then yeah, then what we can improve is this idle break delay time thing, because initially we have set up it as 2, which is a statically typed value, but we can make it more dynamic. To do that, basically, yeah, we need some setup. So maybe we can set this delay time by using our world location, right? Yeah. So in order to get the world location of our character, maybe we can create a new function. Yeah, let's say update location data, and here what we can do, we can get the delta time as well. Maybe we need to randomly change our location at runtime. Just for the reference, I'll take this input, but later on maybe we can use it if it required. And let's get the property access node. So this is a new node provided by Unreal Engine 5, which is we can access our resources in a thread safe manner when it is multi-threaded. So this property access will do that for us. We don't need to make locks and thread safe related mutex and node. Instead of that, we can simply use this property access function or property access node to get those locked resources in a thread safe manner. So let's get the owning actor, and let's get actor location, and I'll promote it to a variable called world location. Okay. And I'll assign it to a category called location data. Okay. And then we need to call this function. So in order to call this function in a thread safe manner, again Unreal Engine has been provided a nice function called blueprint thread safe update animation. So this is a thread safe function, which is a default function provided at the animation blueprints. So we can use this function to invoke such, or to work on those such multi-threaded functions. So let's call this function here, and let's plug the delta time reference here. And if I compile it, it will show this error because I have to make this function as thread safe. Okay, so I'll create a category to keep this sort of blueprint thread safe function called maybe yeah, let's say blueprint thread safe functions. And there are some functions which is not thread safe as well. For example, this initialization and this set animation data, these are not thread safe animation because they have to call in a single threaded fashion at the main thread. So therefore I'll assign those to a new category called not thread safe functions. Okay, so this thread safe function will capture the current location of the owning actor, and it will store at the world location variable. So maybe I can log this string and show you how this works at runtime. And if I show you the output log and clear the existing logs and play it back, you can see now the location has been there, and if I move, that location has been changed, right? So we can use this value as a random seed to generate a random value for our idle break time. So I'll remove this log string and I'll go back to the choose idle break delay time, and there let's use that location, and I'll split it to bins, and maybe to add more randomness we can add these x and y values, so it will return a single seed value for us, right? And that seed value we don't need to consider its magnitude, which is we need to only consider its magnitude. We don't need to consider whether it is negative or positive. So I'll make it absolute. Also, even if it is a float value, since it is a seed, we don't need it as a float, we need it as an integer. So let's truncate the any tailing float values, and let's get the remainder out of 10, and maybe let's add some offset value as well, like 6 maybe, or maybe 5. So the minimum idle wait time should be 5. Maybe I will promote it to a variable. Let's say minimum idle break wait time. So it's 5 seconds, and it will attach some random value below 10, because we take the remainder as 10, and it will add to this offset value, and then we can plug it to here, right? So it will be automatically typecasted to the float because we are expecting it as a float value. Yeah. Okay. Now maybe we can lock this value as well and see how it works at runtime. So I'll clear the existing logs and play it back, and see now it's not playing the idle break animation for each 2 seconds. Instead, it will wait some random time and play it back. See, now idle break time is much more dynamic rather than 2 seconds. But somehow I think this log doesn't work properly, maybe because this is a threaded function. Not sure exactly why is that, but yeah, ideally it should work in that manner, right? We add some sort of a minimum idle break wait time, and we add some random value to that specific offset, and we get the final idle break delay time. Okay, so I think that's how we can implement the idle break logics for our character animation locomotion system, and we'll see how we can improve this further in the next episodes. Thank you.